Hi guys, Heinrich from Shady Horse here. Last time we looked at creating the world lower and upper bounds. What we're going to do now is we're going to spawn a sphere and then just move it in random locations within our defined world space. But before we're going to do that, I would just like to mention that my game Spot the Dot is going to be available on Steam on 30 October, and if you would like to be notified, you can just wishlist it on Steam. Okay, with that out of the way, let's start creating our sphere in random locations. So first thing I'm going to do is create a function to calculate the random location. So we're going to call this get random location in bounds. Okay, and this is going to return a vector. Cool. And we're going to call it random location. Okay, there you go. Now, to calculate the random location, we can start with our lower world bound and with our upper world bound. Okay, just going to split these pins because we're only going to use the x and y coordinates here, and we're going to feed it into a random number generator. So random float in range, and we're going to have two of them, one for the y and one for the x. So our lower bound is going to be in the minimum and our upper x is going to be the maximum, so that's going to be our x coordinate, and then the same for the y. Minimum y is going to go in the minimum and the maximum y is going to go in the maximum. Okay, so with this we can now start to create our vector that we're going to feed in there. So make vector, and we're going to pass in our x there, our y there, but we still need our z. And what we're going to do, instead of using our camera component, we're going to use the actor location. The reason being is if we use a camera component, our object would spawn there, where if you use the actor location, the object would spawn there at the origin of the actor. So let's use the actor location. So get actor location, and let's split the pins because we only need the z, and we pass that in there, and then we can just return our vector in our method. There you go. Now back in our graph, we can actually get that location, that random location. So we can say get random location in bounds, and then we're going to spawn our sphere. So SPA spawn, just take our context sensitive away, spawn actor from class. There you go, and the actor is going to be our BP sphere. That's basically our, I'll fix that now, it's basically our sphere here. Okay, and then we need a location. This just transforms the location to a transform, but uses the location's values, and that should create it. So there you go. So what we need to do now is move it around. To do that, let's just get a reference to our object, so we can just promote this to a variable, and let's call this my sphere. There you go. Let's just change that to a lowercase y. There you go. And now that we have a reference of that, we can actually move it around in our tick. So what we're going to do is we're going to get our random location. So get random location in bounds, and then we're going to move our sphere. So just say set world location of our sphere, and we're going to set the location to this location that we calculated. Okay, and that should be it. But there's a few issues there that I actually left out on purpose, which I'll cover just now. But first, let's just see how it looks like now. So, as you can see, we're spawning, but we're spawning all over the place and incredibly quick. First thing I want you to see is, if you look here in the corners, there's places where the object actually looks like it's spawning outside. See, it's halfway outside, so it clips out. What we need to do to fix that is add some padding. And the way that we're going to do that is actually go back to our random location generator and add some padding in our floating values. So to do that, let me just show you. If we play this, and I see this is bothering me, so what I'm going to do real quick is just stop this from happening so that I can talk to you guys without getting distracted. So if we look at this, if this thing would have been spawned right at that location, which is possible, half of it will be outside. So what we're going to do is we're going to add some padding, so in the X direction to move it up a bit, and in the Y direction to move it basically in, and the same on this one. So the way that we're going to do that is by, we can add this back now, we'll fix that just now. We're going to add some padding in here, so let's just create our two variables. So we're going to call it X padding, and we're going to create another one called Y padding. And while we're busy with it, I'm going to change the settings here to well, the category to settings, and we're going to move the Y padding to that same category as well. Okay, then we're going to use it, X and Y. Now what we're going to do is we're going to take our X location, which is the lower X, and we're going to add our padding. We're going to feed that into the minimum, and we're going to take our upper X and subtract our padding and add that to the maximum. So there's the one. Then we're going to do the same with the Y. So we're going to take our Y minimum and we're going to add our Y padding. Let's move this up a bit. Let's leave it there. And we're going to take our Y upper bound and subtract our Y padding. Okay, and we can add our minimum to our minimum and our maximum to our maximum. And if we run this now, wait, before we do that, let's set these to, let's say 100. Oops, 100. And the Y1 as well to 100. Okay. So if we're gonna run this now, you'll see it doesn't appear to clip anymore, which is cool. So now I think let's slow this down because I can't read that quick. So where we're going to do that is in our graph, put in some timing. Just move this out of the way some more. First thing we're going to do is we're going to basically add delta seconds to some set time and just add it until it's over a certain threshold before we going to actually move it. So we're going to need two variables. The first one is to basically hold our incremental value, and the second one is to get our threshold. So the first one I'm going to call time passed, which is a float, and the second one we're gonna call movement rate. So movement rate. There you go. And the time passed one, we can then just add to the, or rather we can add the delta times to the time passed, and then we can basically check. Well, let's just set this value first. So we can do here set it, else we won't be able to use it again. Set time passed, that one. And then once we have it, we can check if it's more than the movement rate. So from here we can say, is it greater than our movement rate? And then the result of that we can feed into a branch. There you go. And if it's more than that, then we can do our work, and then once we're done, we just need to reset our time passed, else it will happen once, and actually no, it will happen every frame again because it's always higher than that. So let's just set our time passed back to 0, and I think that should do the trick. Let's have a look. So if we play it, nope, didn't do the trick. Let's see what went wrong. Let's go back here. So we added the time passed. We checked that it's, oh, we never set we've never set our movement rate. So let's put that to 0.5. Okay. And let's see what happens now. And there you go. Now, one thing I want to show you guys is the way that we can now iterate through this and play to get just the right speed and just the right space in which we want to move it. So, and that is actually quite easy. What we can do is we can take our padding, make it available outside, both of them, and our movement rate we can also make public. But let's move this also to our settings section, so all three of them would be in the same place. So now if we select our object spawner, you'll see we have our three variables here that we can change. But even nicer is, let's say we've run this inside here. Ignore these because I've forced it to be a certain aspect ratio, and obviously this screen is not the same aspect ratio. But what we can do now, which is quite fun, is we can now change our padding. So let's make this like 300, and we're going to make this one also 300, and you'll see it's now confined to a smaller space. See, it's not right at the border again. I think let's make it even smaller than that. So let's make it 500 and 500. You'll see that's already quite close. But to get more out of this, now we can speed it up or slow it down. So if we slow it down, let's say 0.1. Speed it up, it just goes wild. Or if we move it to 1, it goes really slow. Okay, and that makes it actually quite neat to change our settings and configure it how we would like it for this particular level. And that is it for today. There's one issue that I would like to point out now, and that is, let's just stop this. Actually, I'm running it now. If I eject now and I move my camera, now obviously the camera originally is there, but you'll see currently it is moving nicely in this plane and always in that bounce. The problem, however, is if we're going to take our camera now and we're going to move it. So let's say we move it, oops, that is not the camera. Let's try again. There, that's the camera. And we move it like so, and maybe like so, and maybe we tilt it a little bit, let's say like so, and if we run it now, it's not working anymore. So next time I'm gonna show you how to fix that, so that the object will always be inside this frame regardless of where the camera is pointing. And that will do next time. So to get notified of that, you can just subscribe and ring the notification bell, and then I'll see you guys next time. Thanks for watching, and cheers.